All right, we are going to talk about rate law. Now, the definition of rate law is that it expresses how the reaction rate depends on the concentration of reactants. So our two variables here are reaction rate and concentration. And like many other aspects of chemistry, when we're looking at an expression, really what we're looking at is a relationship. So we want to see the relationship between the reaction rate and the concentration. Now, the general form of the rate law is written as this: rate equals K times the concentration of A raised to M times the concentration of B raised to N. Here, K is our rate constant, and it's a constant that varies, as ironic or as inverted as that might sound. It's a constant that varies with temperature and is different for each reaction. So, as ridiculous as it might sound, it is a variable constant, or a constant that varies depending on temperature for the reaction. A and B are our reactant concentrations. So essentially, what are we reacting with each other to produce the product? The main thing to always be aware of is that when we see these brackets, we're dealing with concentration. And then M and N here are what we're going to be focusing on for this video, and that is reaction orders. So the thing to remember about reaction orders is that they're determined experimentally, and they define how changes in concentration affect the rate. And if we add them together, then the overall order is the sum of those two numbers. So here's an example. Let's consider this equation: 2mg plus O2 leading to 2 MgO. And we're given the rate for this equation, or this reaction, and that rate equals K, the concentration of our first reactant, times the concentration of our second reactant. And in this case, M is 1 for magnesium, and N is 2 for oxygen. And know that the reaction order here is not associated with the subscript, even though in this case that might seem like it's the case. Now we know with the rules of exponents that if there's no exponent written, as is right here, then a 1 is implied. So we are implying an order of 1 for magnesium and an order of 2, or a second order, for oxygen. So because we know that the overall reaction order is equal to M plus N, then in this case, our M is 1, our N is 2, which means that our overall reaction order for this reaction is 3.